Welcome, and thanks for joining us. My guests today are Mark Johnson, the Vice President of Federal Technology for IBM, and Rob Albritton, the Vice President and the Artificial Intelligence Practice Lead at Octo. Rob, I'm going to start with you. There's a lot to get into here, and DoD's always trying to navigate an ever-changing landscape in terms of threats and staying on top of those threats. What do you see as the primary challenge for operations at the edge for DoD agencies?
So I actually think industry has sold a bill of goods to DoD and the government that isn't true when it comes to AI, that AI silver bullet. The problem is a lot of the AI solutions that are being sold to the government or briefed to the government, they're told that they'll solve the government's problems, but they're not telling them the details, right? The details being those AI solutions require massive computational resources to process. Oftentimes, the AI solutions are designed only to be deployed on cloud resources. And the DoD specifically, U.S. Marine Corps, Army, Special Operations Command, those kind of folks are operating around the world in places where they don't have good comms bandwidth, they don't have computational resources, they're not able to push data back to the cloud to crunch on it, right? So the AI solutions need to be developed to work on the edge, on low size, weight, and power devices, and that's not what's being sold to the government.
All right, thanks for that, Rob. Mark, we'll go to you. Obviously, there are more than a couple things DoD has to worry about here. What do you see as those top challenges that they have to be mindful of?
Yeah, it's all about filtering the information that the warfighters at the edge need. Rob mentioned some of the U.S. Marine Corps and Special Operations assets that are on the ground by themselves, but they're also fighter pilots, ships, Humvees that we can put slightly larger computational capabilities into to use some of these AI capabilities that are just coming online now. But unlike the state of the art and what's popping in the news today about general purpose AI, these are going to be special purpose AI developed specifically for those needs. This is something we've been talking about for the 25 years since I've been a Navy test pilot, and we were trying to figure out how do you get the right information into the cockpit at the right time. Well, now instead of just a bandwidth question and a display question, we have the capability now to filter that with an AI machine learning tool that does a much better job of both sending data to the edge and bringing data back from the edge, the right information.
What seems to be the common element here from both of you is that data is really at the core of the future of DoD, that, it is, Rob, to your point, the driver, the training data that AI needs, AI without data is like gas, a car without gasoline or oil. And Mark, to your point, it seems like data is, it's important to get that right ratio of signal to noise, getting actionable information out of the data. Seems like no matter where you slice it, data is at the core of what DoD needs to do going forward.
Absolutely. I'd say it's that the data and how we present the data to the end warfighter, right? So AI can help filter that. AI can also help decide what is presented and how it's presented. And then the data is disseminated back in order to improve the machine learning models.
Yeah, I'd add to that, knowing which data to move and which data to leave as close as possible to the sensor where it's generated is critical as well, right? Again, getting back to where some of these agencies are operating that we support on a daily basis, they don't always have the bandwidth and the ability to push data back to a cloud, right? To crunch on that data, to retrain a model. So as much as possible has to be done as close as possible to the edge. And I think, we'll at some point talk more about our data mesh and data fabric solutions that I think help solve some of those mission requirements.
Okay, well, we've kind of did a quick look at the challenges for DoD, but let's talk a little bit about the opportunities. It is obviously a team effort for what DoD needs to do to solve these problems. How can folks like IBM, like Octo, be a team player in resolving these challenges and driving DoD and to make the transformation that it needs for the future?
Yeah, we act as a partner with DoD in particular, right? We've created organizations and facilities like OLabs, our innovation, AI and emerging technology innovation center in Reston, Virginia. We have ThinkLab, We have IBM has facilities here in DC. O-Labs in particular is a place where we several years ago spent approximately $10 million to develop basically an incubator, if you will, where the government can come sit on site with some of the brightest individuals in data management, thought leaders in AI, thought leaders in blockchain, data mesh, data fabrics, all the various emerging technologies that we're talking about today in DoD, and learn from the best and brightest. And we can share what we've, lessons learned, and they can share requirements with us. And we think that's one way that we can collaborate and meet mission requirements faster than we could if we were just, DoD stays in their wheelhouse, we stay in ours, and we never really come together in one location and collaborate.
Okay, great. Mark, how can IBM help DoD meet the mission?
So I come from the technology side of IBM, right? And so the products that we are delivering, both software and hardware, to combine with the services are essential to making sure that the DoD has what they need. But it's not just about the IBM services, it's also an ecosystem, right? And we want to make sure that we do understand it's a team sport. You mentioned that already. Whether it's AI, getting the data out to the edge, security, all these things take a large ecosystem. And from the technology side, we do work with the big providers for the DoD and for the federal government to make sure that we're listening to what the warfighter needs and then adapting our technologies. And what we do from the tech side at IBM is ensure that the new technologies we're bringing in, the development, the acquisitions are integrated so that it's not hard to uptake that and start using it for end users. That's what we want to be able to deliver in the whole ecosystem.
Mm-hmm. Now, Rob, you said something earlier that's, I think, worth unpacking in a little bit more detail. You said that AI is not a silver bullet, and it's important to be clear-eyed about what AI can do and what it can't do. You want to do some myth-busting in terms of what AI is valuable, in terms of what DoD needs to do, and what it just really is not suited to do?
Yeah, so I think it's important to understand what's required to to develop an AI solution, right? Mm-hmm. So we have a multi-step process that we use called our AI operationalization process, where we take customers through 7 to 9 steps, starting with helping them understand their problem first. Mm-hmm. Not all problems are best suited to be solved with AI. Some are just a high-performance computing problem where you're just speeding up the analytics. Some are an AI problem where you're doing predictive analytics and things like that. But customers have to understand their problem first and foremost. So we do that. Second, they need to understand what it takes to create an AI solution. So again, we've talked about computational resources, right? It takes a lot of computational resources. So compute power to train a machine learning model. It takes a lot of data to train a machine learning model. So we take the customer through that journey of understanding whether or not they have the resources to actually solve their problem with AI. Sometimes the answer is no, and they need to invest more in their infrastructure, in their pipelines, data mesh, data fabrics, things like that, to get data into their own ecosystem to train their models. So that's really how we take the customer through a journey of understanding, what can and cannot be solved with AI and whether it's the right solution for them.
Okay, Mark, and then, DoD's problem is never that it doesn't have enough data. It has, a treasure trove of the data. Right. It's about getting, actionable intelligence out of that data, getting, maximizing the utility of that data, and understanding where the gaps are, getting that data as good and as of a quality as it can. You mentioned kind of this machine learning use case in terms of getting data to and from that rugged edge out in the battlefield or what have you. What are some good housekeeping, good principles for DoD to keep getting that good actionable information in near real time?
Well, I'd like to add on to what Rob was talking about and for the compute necessary to do the machine learning models, right? It takes a massive amount. So what we are trying to do from IBM is to make it easy to set that up, to be able to use that, and then to move that data because it is a very similar infrastructure underneath it. And that's where our Red Hat acquisition comes in, right? We not only have OpenShift and Linux to be able to deploy in many different places and a bunch of different clouds, the hybrid cloud point, but also with MicroShift coming online now, we can push things to the edge, very lightweight, small devices, so that it becomes easy as you pull that data off, you understand where it's coming from, you understand where it is going, you can scale up your resources across multiple clouds if you need the resources right away. And understanding all those and blending them together is what we're trying to do from a technological point of view to solve that problem. And that includes, like we talked about before, deploying on vehicles perhaps that have more compute than just a manned portable system can have.
All right, well, you mentioned the hybrid cloud. Let's get into that in a little bit more detail. In a hybrid cloud environment, what workloads should DoD agencies prioritize as being on-premise, in the cloud, on the edge? There's a lot of things to balance there.
Yeah, that's a great question. One thing I'll say right up front is I've always been an advocate of the hybrid cloud. DoD has unique use cases, and I think any big enterprise really will always be hybrid cloud. Thinking that everything is going to go into the cloud, everything is going to be on the edge, everything is going to be on a premise data center, is just not the modern world, right? And there's challenges with that. IBM's committed to helping our customers work through those challenges and make it easier. But when you think about highly classified, secure environments, those belong in data centers. Now, I know there's JWCC out there, which has classified environments, but really those are private clouds if you look at the way it's built, right? Mm-hmm. It's not open for anybody. It's not a public cloud. But there still needs to be that ability to move into a public cloud for the right workloads. There's lots of workloads that the DoD has to assist families, for instance, to assist them in deployment of individuals, things that aren't necessarily classified and can very easily be deployed there, and that makes them easy to access, right? So it's about a balance between the security necessary, the compute power necessary, and the ease of access.
Yeah, well, it always comes down to, what goes where, right? Where do the crown jewels go? Where does the less sensitive data go?
Absolutely.
It is obviously several different orders of sensitivity to that data. Rob, to that point, it's a couple of things to consider. What should agencies consider in deciding what goes where?
Yeah, so from my perspective, I think more about the physical workload itself, right? Mm-hmm. And when I think about physical workloads, I'm thinking about computational requirements, data storage requirements, and where those all fit in the machine learning operations pipeline, right? So training your models all the way to deploying them, doing your inference, maintaining them, all of the life cycle that's required to keep a machine learning model operational in a combat environment, in an operational environment, right? Or on an analyst workstation. So training a machine learning model takes a lot of computational resources. I think we've hit on that probably 10 times already today, and we probably will a few more times. But it's true. That's where you need compute, right? So probably cloud computational resources, maybe on-prem data centers, right, if you're doing secure compute. But when it comes to your inference workload, actually doing analytics with your AI, your machine learning model, that needs to be done as close as possible to the edge, in my opinion. So that's where you're talking about MicroShift, right? And using MicroShift to deploy things like our Hatteras MLOps platform that can monitor a machine learning model in combat on a low size, weight, and power embedded GPU, for example, or other low size, weight, and power devices that now, quite frankly, can be put on body. Soldiers are starting to deploy with on-body compute. Mm-hmm. It can be done on phones. It can be done on, really low size, weight, and power devices. And so I guess to summarize is inference at the edge, right? Training probably on larger compute infrastructure on-prem or in the cloud.
When we talk about AI and the value proposition of deploying AI, I think one clear one is always speed, right? Like it's always going to be able to do some functions much faster than the human operator can. What is the best approach to speed up that evolution of AI being deployed at DoD and getting back to the whole name of the game here, which is getting more information out of this deluge of data that's out there?
I think it's about using hybrid cloud wisely. First of all, we have to be able to spin up environments, test things out, try it, see what results happen, and then tear them down very quickly and put new ones in place, whether it's a machine model, whether it's a total new application or a way of presenting the data. Fail fast, I'd like to say succeed fast. That was what we'd like to see, but we know that as we do this and test, the way to get out there and really change the game is to allow operators to have the input on these, which rapidly iterate new technologies.
Yeah, I would agree. We end user design, human centered design, in the Army, soldier-centered design, which is what we work on at PEO Soldier, for example, and with some of our Army customers. This iterative approach to having soldiers or the end user involved at every step of the way when you're developing the technology. But specifically from a technological perspective, I think hitting on machine learning operations again. Right now, it takes some DoD programs 3+ months to get data off the battlefield or out of a tactical environment back to the cloud or the on-prem data center that they are going to train that machine learning model in. So they retrain the model, they push it back downrange. It's a multi-month process. That's far too long for our warfighter, right? The intel, the things they're looking for if they're using computer vision on the battlefield change in that amount of time. They change in a matter of a single mission, let alone 3 or 4 months down the road, right? So I think we have to be able to iterate on our machine learning models as quickly as possible, meaning we've got to get ML ops as close as possible to the edge. So train a machine learning model on your cloud computational resources, push it to the edge, do your inference at the edge. When drift or other model degradation is detected, right, that model stops identifying a tank as well as it was trained to do. You need to be able to retrain that model as quickly as possible and keep it performant while in combat, if possible.
It strikes me in hearing all of this that, for DoD, this is not just a nice to have, this is a need to have. And, they've been pretty clear about, the speed at which they need to get there. I think they've eyed 2025 as a period of AI readiness for DoD. That is obviously kind of a broad and maybe a vague term. From your perspective on things, what does AI readiness mean for DoD, and what are going to be the key criteria of getting there?
So we've talked a lot about the operational aspects of AI and how it can change decision-making on the battlefield. A couple of things that go into that readiness that we haven't talked about today are the security, right? How do you secure the models, secure the data, secure in transport, secure the end units, right? And how do you do it ethically, right? A big factor on this is we talked about machine vision. How do you ensure that what it's targeting is that tank and not a school bus? And we really need to watch what can be done and make sure that our AI models can't be used for evil at the time we're developing, right? Yeah. And then securing it, I think the big challenge for us is quantum. I read recently that there's a 50% chance there will be a quantum computer by 2030 that can break 2048-bit encryption. That's 7 years away and should panic everybody in the DoD because it'll take us longer than that to upgrade our encryption, right? And right now, people are collecting data and storing it to try to encrypt it later. So we need to think about what is quantum safe encryption. IBM is leading with that, with NIST, developing new quantum safe models to be able to be used by the DoD and across federal government. So those are two aspects, I think, of true readiness beyond the operations that we need to consider.
Yeah. Rob, AI readiness, what's going to look like?
Yeah, I'll add on to the security side. I agree. I think another way to think about security is also going back to your ML ops platform and how you're detecting drift and all these different kinds of model degradation on the battlefield. Getting to the point about the school bus, right? That's a very real risk, right? When we deploy these computer vision models, we don't really know. At times they're like a black box, right? Mm-hmm. There are a lot of DoD programs trying to get after the XAI, explainable AI problem. And that is critical. We need to be able to tell what that machine learning model is doing in the background, right? How is it arriving at that answer? And then if there are issues with it, all machine learning models drift over time. They all degrade over time. There's not a single one that doesn't, right? We need to be able to monitor those when we're using them. And a non-technical user has to be able to understand when that model's not working properly so that they're not calling for fire on the wrong target eventually or something to that extent.
Yeah, yeah. You know, obviously many agencies are dealing with a lot of these issues. You know, I think the thing worth underscoring in this conversation is the unique element of this for DoD is always that rugged environment that they operate in. You know, the battlefield is going to be a much more challenging area for these AI systems to train up in, as opposed to, you know, a controlled sandbox environment that other agencies might have the luxury of having. You know, with that in mind, to underscore the rugged environment DoD has to operate in, you know, how can folks like you know, help the AI overcome those challenges and get trained up, learn fast, fail fast, things of that nature?
For IBM, I'd say it's around the various technologies that we have, right? We can deploy technologies that will allow our DoD end customers to use clouds, different clouds, rapidly move to different clouds, Red Hat being a major part of underpinning that technology, and then being able to flex the models, flex the data that you use, and quite frankly, when the system fails, which it will, how do you fail gracefully, right? And be able to pick up something for the mission. As a Navy pilot, it's always about mission to me. I try to bring that back to my team, and we're always working together in a group with the end customer, with the ecosystem, with services to be able to deliver the right thing for the customer, and which is always changing. That's what I love about this, you know, challenge and this opportunity here in front of us is it will constantly be evolving, and we have to constantly keep ahead of our adversaries.
Yeah, I'll touch on the tech side. I think if you've been following the news, some folks probably saw the news about Red Hat deploying a microshift instance on a low size, weight, and power device that was on a UAS that Lockheed built and deployed, and they proved that they could run a machine learning model on the aircraft. When that machine learning model started to degrade, they could retrain it on the ground and push a new model to the aircraft. So we've heard about, you know, the F-35 and F-22, but I think it was the F-35 that perhaps Kessel Run or one of the Air Force groups was able to update software in real time, right? So they're pushing software to an aircraft and updating it. 20 years ago, that's unheard of. That was almost science fiction, right? And now we're doing it with machine learning as well. Where we're pushing new models directly to an aircraft that's flying in combat potentially, right? And I think that ability is only possible when you have technologies like what Red Hat and IBM are working on, and the ability to secure them and push them as close as possible to the edge.
Okay, well, you know, we've covered a lot of ground here, but I think to bring it home, let's talk a little bit more about how, you know, what is industry's responsibility for helping DoD solve these big problems, navigate that rugged edge, and what role can you guys play in helping solve these very big, complex problems for DoD?
I think a big part of it is actually the acquisition system, right? It's not just the technology, but we talk about rapid iteration, and our acquisition system is just not set up to do that. So that's where we have to, in its industry, step in, help DoD realize what can be done within the bounds of the acquisition system. How can we provide rapid updates? It really comes down to the services being delivered by, you know, Octo and IBM Consulting to construct a good statement of work that allows us to provide this service and this capability to rapidly iterate with the warfighters. That's the biggest challenge to me has been our acquisition system is built to buy planes and ships, you know, and not as fast as AI is moving.
All right. Well, Rob, I think you get the last word here.
Yeah. So I guess 2 points. One, I think there are a lot of individuals like the employees we have at OLabs, at Octo, at IBM, who are quite frankly, in many cases, technologically, they're geniuses, right? I mean, just brilliant individuals who feel like they have a patriotic duty to give back to the government, right? Give back to DoD. They have special skills that they need to share with DoD, and we do that, right? So it comes down to culture. That's part of our solution. And you're spot on with the acquisition process, right? It is dated. We can educate the customers, though. Oftentimes, we've written white papers about agile acquisition processes that we've used at the National Geospatial Intelligence Agency and other places, right? That enable the government to not get locked into, long 3, 5, 7-year contracts that are billions and billions of dollars. There are more agile ways to do it that prevent the government from getting locked into a specific vendor or locked into, specific terms in a contract. And then you throw AI in there, and acquisitions become even more complex, right? Who owns the data? Who owns the model itself? The weights, all that kind of stuff. A lot of questions around it, but I think we are able to educate the customer, the DoD, and it's our duty to do so.
All right, well, we have covered a lot of ground here, but to bring it home here, Mark, just tell me a little bit more about industry's responsibility in helping DoD tackle these big complex problems and industry's role in getting that done.
Yeah, I think, first of all, industry needs to help DoD with acquisition. Right? It's built to buy ships and planes and is not agile enough to be able to keep up with the pace of AI and machine learning change and IT acquisition in general. So what we can do is work with the warfighter more closely to understand their needs, write a good statement of work, and then provide some flexibility in the acquisition process so that changes can be made without having to start over, bring in a new requirement, things like that. As we do that acquisition process and we improve it, we will get closer to the warfighter, closer to the mission, which is near and dear to my heart. And a big part of why we acquired Octo, because they are so close to the warfighter.
We are. One of the things we've done really well at Octo, and especially in O-Labs, our innovation arm of Octo, is we've created these multidisciplinary teams. And each of those teams have domain experts on them, right? So folks from the SOF community, Special Operations Forces, folks from the Intel community, individuals who have deep expertise, have spent a career doing those jobs. They are on site with our technical teams, telling our technical teams, yes, that would be used in operations. No, that wouldn't be used, right? So it's that iterative feedback process. And we've done a really good job of doing that. And so just about everything we develop ends up being operationalized at some point. That's hard, though, when you're as small as Octo was, right? So when you bring in the size and the global reach of an IBM, we're able to more easily take things from prototype phase, idea phase, to actually fielding it and scaling it to an organization the size of the U.S. Army, for example. And I don't think we could really do that without an IBM.
All right, well, great conversation, but I think we're gonna have to leave it there. I'd like to thank today's guests, Mark Johnson, the Vice President of Federal Technology for IBM, and Rob Albritton, the Vice President and Artificial Intelligence Practice Lead at Octo. I'm your moderator, Jory Heckman, and you're listening to Federal News Network. Now let me send you back to the studio for more on the DoD Cloud Exchange.